This is a ladder logic diagram. Two vertical rails with a rung of logic strung between them. So what is a ladder logic diagram, really? It is the quiet drawing that runs most of the machines around you. Every factory line, every motor starter, every automated door. Chances are a diagram like this is in charge. By the end of this video, you will know exactly what it is. You will know why it looks like a ladder and how to read one at a glance. No PLC experience needed. Let us start with the shape. Look at it, and the name gives itself away. Two tall vertical lines down the sides. Short horizontal lines crossing between them. It is a ladder, rails on the outside, rungs in the middle. That shape is not decoration. It is the whole idea. The two vertical rails are the sides you would put your hands on. The horizontal rungs are where all the work happens. You read them one at a time, top to bottom, exactly like climbing down. Every ladder logic diagram, however big, is just this. More rungs stacked between the same two rails. Learn one rung, and you have learned the format. Now, what are the rails actually for? Power. The left rail is the live side. Think of it as always hot, always ready to push current. The right rail is the return, the neutral, the way back. In the old days, these were called L1 and L2, and they were real live wires. Between them, each rung is one rule of logic. You read a rung left to right, like a short sentence. Conditions come first on the left. One result sits on the right. And here is the key. Power only crosses a rung when the left-hand conditions allow it. Block the path, and nothing happens. Clear the path, and the result switches on. Quick note. Every diagram in this video is drawn in a free editor that runs right in your browser, CircuitDiagramMaker app. No install, no sign up. The link is below, so open it in a second tab and follow along. So what fills a rung? Just two kinds of thing. Two building blocks, and you will see them everywhere. The first is the contact. Contacts are your conditions, your inputs. They're drawn as two small vertical lines, like this. A normally open contact asks a simple question. Is this input on? If yes, it closes and power passes. A normally closed contact has a slash through it and asks the opposite. Is this input off? The second block is the coil. One coil sits at the far right of every rung, drawn as a pair of curved brackets. The coil is the output, the action. It is the motor, the valve, or the lamp that the rung switches on. Contacts ask, coils act. That really is the entire alphabet. And from those two blocks, you get real logic. For free, just from how you arrange them. Put two contacts side by side, in series, and both must be on for power to pass. That is an AND. Stack two contacts in parallel branches, and either one on its own will do. That is a NOR. And a normally closed contact, remember, is true while its signal is off. That is a NOT. And, or not, the whole of Boolean logic drawn as wires. That is why engineers reach for it. But a drawing on paper does not do anything. What brings a ladder diagram to life is a small computer called a PLC, a programmable logic controller. And it runs the ladder in a very particular way called the scan. Here is the cycle. First, the PLC reads every input at once, every button, every sensor, and takes a snapshot. Then it solves every rung, top to bottom, against that snapshot. Then it writes the results out to the outputs, the motors, and the lamps. Then it does the whole thing again, and again, thousands of times a second, forever. That is the scan. Read, solve, write, repeat. It is why a machine reacts the instant you press a button. The PLC is already, always coming back around. So why does it look like this at all? Why rails and rungs, and not lines of code? The answer is history. Before PLCs, machines were controlled by panels full of physical relays, real coils and real switches, wired together in cabinets. Electricians read those panels using exactly this drawing, two power rails, and rungs of contacts and coils. It was called relay ladder logic. When the PLC arrived in 1968, it had one job: replace those relay cabinets. So it kept the drawing the electricians already trusted. Relay ladder logic simply became PLC ladder logic, almost unchanged. That is the secret to why it has lasted. It was never new. It was familiar, and familiar one. Today, ladder logic is everywhere the physical world meets a controller. Factory production lines, packaging and bottling machines, motor starters and conveyor systems, water treatment, elevators and building automation, heating, lighting, and access control. If a machine has to do the same reliable thing over and over in the real world, odds are there is a ladder diagram behind it. Let us make it real with the single most famous rung in the field. The motor start and stop. On the rung, a normally open start contact, then a normally closed stop contact, and a motor coil on the right. Press start, power flows across, and the motor turns on. But release the button, and it stops. Nobody wants to hold a button all shift. So we add one clever branch, the seal in, a contact driven by the motor's own output, wrapped around start. Press start once, the motor latches on, and this contact holds the power path open by itself. Press stop, the path breaks, and the motor drops out. One rung. That is real machine control, and every idea in this video working at once. And you do not have to imagine it. Here is that exact circuit, live in the free editor. This is CircuitDiagramMaker.app with a DOL motor starter open, the hardwired cousin of the rung we just built. Every part is real, with a label and a value you can click. Now watch. Hit Simulate, run the DC analysis, and real numbers land on the wires. 24 volts from the control supply, current flowing along the energized path, right there on the diagram. This is the fastest way to see that a drawing actually works. One honest note, this editor draws and simulates the circuit. To execute a ladder program, scan by scan, inputs driving outputs, live, that needs a real PLC. Our sister tool at plcsimulationsoftware.com runs one. Both links are below. So that is what a ladder logic diagram is. Two rails of power, rungs of logic, read left to right, contacts that ask, one coil that acts, and a PLC scanning it all, top to bottom, forever. This video is the map. Now pick your path. Want to build one yourself? Watch how to draw a ladder logic diagram. Want to decode one on site? Watch how to read a ladder logic diagram. Want patterns you can reuse? Watch the 5 worked examples. All 3 are linked for you. Open the free editor, grab the motor starter template, and press a rung to life. The link is below. Subscribe for a new diagram explained every week, and I will see you in the next one.